Hi, we're going to understand pure time differential equations by looking at a chemical reaction. This is an industrial reaction, so it's producing a chemical at the rate of kilograms per minute, and there's a formula for the rate of production of the chemical, and it's given right here. P prime of T is 500 e to the minus 2 times T. Now the question asks us to determine the amount of chemical produced, P of T, as a function of time. And the question asks us to assume that initially there's no chemical present, so P of 0 is equal to 0. Notice P of T is the amount of chemical produced, and so P prime of T is the rate of chemical production. And we know what P prime looks like. It's drawn out here. It's a decaying exponential, and it starts at 500 and drops down. So this is a fast rate of production initially. And then as time progresses, we slow down and we have a slow rate of production. Okay, so if we're going to calculate P of T, we want to evaluate the integral of P prime of T. So P of T is equal to the integral of 500 e to the minus 2t dt. And we can pull out the 500 here and write it as 500 times the integral of e to the minus 2t dt. We use substitution at this point, and so u is equal to minus 2t. So du is minus 2 dt, and if we want to write it in terms of dt, dt is minus 1/2 du. And so substituting in, we have 500 times the integral of e to the u times minus 1/2 du. We can pull out the minus 1/2, and so we get minus 500 over 2 integral e to the u du. Now we know how to integrate e to the u. We have integral of e to the u is just e to the u plus a constant. And so we have minus 500 e to the u plus a constant. And finally, we can write that in terms of t as minus 250 e to the minus 2t plus a constant. Okay, so we have a constant here. There's something we haven't used yet, and that's the fact that p at 0 is equal to 0. So let's apply this initial condition here. And so 0 is equal to P of 0 is equal to minus 250 e to the 0 plus a constant. E to the 0 is equal to 1. And so that says that the constant is equal to 250. And so finally we can write P of T is equal to minus 250 e to the minus 2t plus 250. If we want to, we can pull out the 250 and write that as 250 into 1 minus e to the minus 2t. That's our formula for the amount of chemical produced, P, as a function of T, time, that the question asks us to calculate. But let's get a feeling for what it looks like. When time is equal to 0, P of 0 is equal to 0. So we know it starts at 0. And as time progresses, let the limit as time goes to infinity, P of T, be equal to limit as time goes to infinity of 250 into 1 minus e to the minus 2t. So this term is going to go to 0 here. And so this is going to be equal to 250. And so let's put 250 here. This is a horizontal asymptote for P. And so we know that P prime is positive, as shown in this graph here. So it's an increasing function with a asymptote of 250. So it looks like something like this. So eventually, 250 kilograms of product is produced. And at that point, the chemical reaction is going so slowly that the amount of product never exceeds 250 kilograms. And so with this pure time differential equation, we can go from a rate of production to the actual amount that's been produced. In this case, we're applying it to the rate of creation of a chemical product from a reaction, but it could be applied to other similar kinds of problems.